Good day, the topic is transmission of pressure. Transmission means transfer. Therefore, transmission of pressure is the transfer of pressure through layers of immiscible fluids. Thus, a pressure applied at any point in a liquid at rest is transmitted equally and undiminished to every point in the liquid. Next, what is immiscible fluids? So these are fluids that are incapable of being mixed or blended together. An example is oil and water. And for our notes, fluids are arranged according to its mass. The heavier fluids settle at the bottom. Based on the discussion of fluid properties, the major properties and determinants of how heavy the fluids are density, unit weight, and specific gravity. So let us consider this airtight jar containing 4 fluids, 3 liquids, and 1 gas. Again, fluids are arranged according to their weight. To determine the transfer of pressure, let us note the relationship of depth and pressure, and by principle, as the depth of submersion in the fluid increases, the pressure increases. Consider points of interface and ends of the layers of fluids. Number in series from top most surface by noting that first point is at the surface of fluid and gas. Why? Because gas is free form. Start at point 1 with the space occupied by air. Air exerts same pressure on all surface it comes in contact. In pressure diagram, P sub A is uniform. Thus, the pressure at point 1 is the value of the air pressure or PA. Next is point 2. The weight or pressure of air is transferred to liquid A. And in addition, the equivalent pressure or weight of liquid A. In diagram, from the top surface of liquid A, the pressure will increase until its lowest point, with the value of maximum pressure as P sub LA, that is equal to gamma of liquid A times height of liquid A. Therefore, at point 2, the total pressure is PA or the air pressure plus the pressure for this liquid A. Next is point 3. The pressure or weight of two fluids above will be transmitted. In addition, we will consider the equivalent pressure or weight of liquid B. In diagram, from top of liquid B, pressure will increase until its lowest point, with maximum pressure as P sub LB equal to gamma of fluid B, multiply that with height of liquid B. Therefore, at point 3, the total pressure is equal to PA plus the pressures of liquid A and liquid B. At the last point, point number 4, again, the weight or pressure of fluids above will be transmitted or transferred. In addition, we will consider the equivalent pressure of liquid C. In diagram, pressure will increase from top to base with the maximum pressure that is P sub LC equal to gamma of liquid C multiplied with the corresponding height of liquid C. Therefore, at point 4, the total pressure is the sum of all transmitted pressure and including the pressure of the last liquid, which is liquid C. Therefore, by principle, the weight or pressure is transmitted to the fluid below. Thus, in equation for layers of fluids, the value of pressure at any point is equal to PA, that is the air pressure, which is equal to 0 if it is exposed to the atmosphere. Again, the gauge pressure is equal to 0 if we are dealing with a surface that is exposed directly to the atmosphere. So next, we will add this to the sum of P sub Li. So this is now the pressure combination of involved fluids. And for the pressure of the liquids, that is gamma times the height. So let us now consider our sample problem. So for the problem, a pressurized closed tank contains 4 fluids, air, and 3 liquids. The properties of liquids are presented in the table. So for the liquid, we have mercury, oil, water, with the corresponding specific gravities and the equivalent depth or height inside the tank. So if the pressure of air inside is 10 pounds per square foot, determine the following. A. Pressure at the bottom of the tank. B. Pressure at the interface of water and mercury. C. Pressure at the mid-height of water. So before we compute the required pressure values, consider the diagram with arrangement of fluids inside the tank. Take note of the specific gravity of the fluids. So again, the heavier fluids must settle below. Therefore, the arrangement from the bottom is mercury, followed by water, then oil, and finally, that is air. So mark with number in series at the interface and ends of the fluids, starting from the surface of oil, or the one exposed to air. For the first requirement, determine the pressure at the bottom of the tank. That is equal to the total pressure until point number 4. P, therefore, is equal to PA plus the summation of the pressure of the different involved liquids. So replace with pressure of involved fluids. Those are oil, water, and mercury. And P is therefore equal to the gamma of the liquid times the height of that liquid. So for unit weight of liquids, consider the formula of specific gravity. Therefore, gamma is equal to the specific gravity of liquid times the gamma of reference fluid, that is water. Substitute the values. P now is equal to PA, that is 10 pounds per square foot, plus specific gravity of oil, that is 0.8, times the unit weight of reference fluid, which is water, 62.4 pounds per cubic foot. Then multiply to the height of oil, equivalent to 3 feet, plus gamma of water, again 62.4, times the height of water, which is 4 feet, then plus we have the specific gravity of mercury, so 13.6, times the gamma of water, 62.4, times the corresponding height of mercury, which is 1.25 foot. P is now equal to 1,470.16 psf. So for the second requirement, determine the pressure at the interface of water and mercury. So if we say interface, it means the contact surface of the two fluids. For this case, it is equal to the total pressure until point 3. So the interface again of water and mercury. And for this P is equal again to PA plus the summation of the pressure of the involved liquids. So again, replace with pressure of the fluids. So we have oil and water only. So again, there is no contribution for mercury since mercury is below now the point of consideration. So there is no contribution in terms of pressure or otherwise weight. So to continue, the pressure P is equal to the gamma of the liquid times the height. And for unit weight of the liquids, consider the formula of specific gravity. Therefore, gamma again is equal to the specific gravity of the liquid times the gamma of the reference fluid, that is water. Substitute the values. Our P is equal to PA, that is 10 PSF, plus S of oil, 0.8, times gamma of water, 62.4, times height of oil, 3 feet, plus the gamma of water, that is 62.4, times the height of water, which is 4. P therefore is equal to 409.36 pounds per square foot. And for the last requirement, so at the mid-height of water, so the total pressure is until 2 feet below the top surface of water. Because again, this is at the mid-height of water. So for P now, P is equal to PA, the air pressure, plus the sum of the pressure of the involved fluids. So for the involved fluids, we have oil and water. But take note that for the water, this is up until its mid-height only. So for the pressure, again, P is equal to gamma of the liquid times the corresponding height. So for unit weight of liquids, consider the formula of specific gravity again, that is gamma equal to the S of the liquid multiplied to gamma of the reference fluid, that is water. Substitute, P is equal to 10 pounds per square foot plus S of oil, that is 0.8, times gamma of water, 62.4, times height of oil, which is 3, then plus the gamma of water, 62.4, times the height of water, that is 2 feet. Again, not 4 feet because we are dealing with the mid-height of water only. Thus, the pressure until the mid-height of water is about 284.56 pounds per square foot. Okay, so that's it for the transmission of pressure. Take care and God bless.